In this question, we have to find the equation of the circle. We know that the equation of the circle is given as x minus a whole squared plus y minus b whole squared is equals to r squared, where a comma b are the center of the circle and r is the radius. So this is the center and r is the radius. So we have the center as 5 comma 1. So we can write x minus 5 whole squared plus y minus 1 whole squared is equals to r squared. Now, what we need to understand is that this is the center and this is a point that lies on the circle. So the distance between these 2 points will be the radius. So we can find the radius by using the distance formula. So r would become x2 minus x1 plus y2 minus y1 whole squared. So this would become minus 1 minus 5 whole squared plus minus 2 minus 1 whole squared. We get 36 plus 9, which is square root of 45. So the equation would become x minus 5 whole squared plus y minus 1 whole squared is equals to square root 45 whole squared, and cancelling out the square root with the square, we have x minus 5 whole squared plus y minus 1 whole squared is equals to 45. In the next part, we have a point C such that AC is the diameter of the circle. Point D has coordinates 5, 16. We have to show that DC is a tangent to the circle. Okay, so to show that anything is a tangent, what we first have to understand is that if we have a circle and we make a radius or a diameter, the tangent always makes a right angle with the radius or the diameter. We also know that this point is B, which is the midpoint. So let's say if this was A and this is C, B would be the midpoint. So we can find the coordinates of C by using the midpoint formula. We know that the midpoint is 5, 1, the coordinates of B. The coordinates of A are given, which are minus 1 and minus 2. So we can write this as minus 1 plus x upon 2, comma, minus 2 plus y upon 2. So the coordinates of A are minus 1 and minus 2, yes. So now equating 5 with the x coordinate, we have 5 is equals to minus 1 plus x upon 2, and 1 is equals to minus 2 plus y upon 2. Simplifying this, we get x is equals to 11 and y is equals to 4. So the coordinates of C are 11 and 4. Now the coordinates of D are given as 5, 16. And we have to show that DC is a tangent. So what we can do is we can find the gradient of AC, we can find the gradient of DC, and we can show that they're negative reciprocals of each other. As if two lines are perpendicular, their gradients are negative reciprocals. So the gradient of CD would be y2 minus y1. So we can write 16 minus 4 divided by x2 minus x1, which will become 5 minus 11. So this would be 12 divided by minus 6, which is minus 2. And the gradient of AC would be, so the coordinates of A are minus 1 and minus 2, and the coordinates of C are 11 and 4. So we can say y2 minus y1 would be minus 2 minus 4 divided by minus 1 minus 11. So this would simplify down to become positive 1 upon 2. Now, as we have the two gradients, to show that they are perpendicular, we can just show that the two gradients when they multiply, the answer would be negative 1. And this shows that the two lines are perpendicular. So multiplying minus 2 by half, as we have a minus 1, hence it's proven that the DC is perpendicular to the circle. As AC is the diameter and the gradients are negative reciprocals, so we can say that DC is a tangent to the circle.